Hello, and in this video I'm going to talk about exponential functions. First of all, let's define what an exponential function is and look at some examples of what an exponential function is and how it grows or decays, increases or decreases. So an exponential function increases or decreases by a multiple. That means it is either multiplied by a whole number to increase or multiplied by a fraction like 1/2 to decrease. So it's multiplied by that factor each time as it increases. A linear function increases or decreases by a specific value. That means it's added. Certain values are added each time. To review, that's what linear functions do. We're going to give you an example of two different charts here. If we look at this chart specifically, we're increasing here on the x values by 1, and on the f of x values we're increasing by 6. So this is linear. Okay, it's 6 divided by 1 each time, so it's changing by 6 over 1. Okay, so our equation there is y equals 6x plus a b value, and you would then plug in a point like 112. Put 12 in here. 6 times 1 plus b, and b would be 6 in this case, so we'd end up with f of x equals 6x plus 6 for its equation for that one. It's linear, it goes up by the same amount, and increases by the same ratio, 6 to 1 each time. Now this one here, on the second example, g of x, it increases by 1 also on this part. But in this case, this one goes up by 3, this one goes up by 6, this one goes up by 12. That means it's not increasing by the same amount, so it's not linear. So what we need to do is check to see what the factor might be. So if it's exponential, when we divide these values, if we divide 6 divided by 3, and 12 divided by 6, and 24 divided by 12, we should get the same value each time. So we take a look at just these values here on the g of x values. We're looking to see whether or not they have a same ratio. Now we can only look at this ratio if they go up by the same amount. They have to increase by the same amount. In this case we're increasing by 1. If we increase by 2, it's also what we're looking for, that multiple or factor here. And that's the amount that you're multiplying by here, or dividing by, multiplying by a fraction. In this case, every time we multiply by 2 in this case. So if we multiply 3 by 2, we get 6. 6 by 2, we get 12. 12 by 2, we get 24. It's increasing by 2. Now, an exponential model follows this model right here. It's not like linear, y equals mx plus b. It is f of x equals a times b to the x. Or if we're dealing with time, then our variable is t instead of x. And in this case, it's x, so we can use this model to get our answer for this. We know what a is. A happens to be the first value, or the initial value of the function. It's the y-intercept, or the initial value. And b is the rate of growth or the rate of decay. In this case, that's 2 because we've divided and found that growth or rate. Now if we're given a percentage, then we're going to add that percentage on to 1 so that we get 1 point something. If we're decreasing, it'd be 1 minus that interest rate, so this would be a rate. So if we know a rate of growth or decay, then we're going to add it to 1. In this case, we know the actual growth rate is 2. So that's going to be the b value. So in this equation up here, we're going to get g of x equals some a value times 2 to the x power. Then we can just plug in the first point again to figure out what a is. So we know the point for the first point, x is 1 and g of x is 3. So it would be 3 equals a times 2 to the first power. Well, to solve for a, we just need to divide by 2, so a is 3 over 2. So our equation here for g of x in this problem is 3 over 2 times 2 to the x power. That's our equation for this model right here. Okay, now I'm going to give you an example of where this is happening in a problem where we have a rate of growth. So I'm just going to take some problems out of the textbook that's online. Okay, we'll take a look at a couple problems here. The first problem, let's do equations with 2 points. So these are 2 points. I took these right out of the book. We're going to use the equation that I had before, which was f of x equals a times b to the x, to find out what this equation is. Now I have 2 points. What we have nice here on this one is we have the y-intercept. So since they gave us the y-intercept, they gave us the b or the a value in the problem, not the b value. A value in the problem is given. So our function right now is 3 times b to the x. Now what we want to do is plug our second point in here and see if we can figure out what x is. So our second point, our f of x is 75, so we're plugging in this point to this function. So we get 75 here equals 3 times b to the second power. So what we need to do is divide by 3 first. So if we divide by 3 on both sides, we get 25 equals b to the second power, and then to get b, we need to take the square root of both sides. The square root to get rid of the square, so b is going to be equal to 5. So my equation is f of x equals 3 times 5 to the x. And we can check that. Put in 0. 5 to 0 is 1. 1 times 3 is 3. Okay, and then we put in 2. 5 to the second power is 25. 25 times 3 is 75. We just checked both points given in this equation to make sure it works. All right. Now in the second example of the same type, we don't have the y-intercept first. So what we're going to do here is we're going to use a system of equations and substitute. That's what I wrote up here to begin with. We didn't have to use a system on the first one because they gave us the y-intercept. So it's system simplified. So we're going to write the system here, and we're going to do a substitution to find the answer. So we're going to basically use f of x equals a times b to the x. We're going to plug in f of x, and we're going to plug in x for each one of these. All right, so on the first point, this point right here, our equation is going to be 4, because that's f of x equals a times b to the negative 3 power. And our second problem, it's going to be, plugging it in, it's going to be 2 equals a times b to the third power. Okay, 'cause that's 3. All right. Now, the substitution I would say would be the easiest here is to solve one of them for a and then just plug it in. So either one of them, since I don't want to have to take a root or any kind of negative root or whatever here to get rid of this, I would solve this for a here. So I take the red equation here, and solve for a by dividing 4 divided by b to the negative 3rd power. So we divide by this. We divide by b to the negative 3rd. b to the negative 3rd. So we get an a value of this. Now we can take this a value from this equation and put it in for this a value in this equation. So our equation that's in green still starts out with 2, but this a value here is going to become 4 over b to the negative third. And then we're multiplying by b to the third. So this is what we have. Now, we want to simplify this right-hand side. So this is over 1. This part is over 1. So we can rewrite it as 2 equals 4 b to the third over b to the negative third. Now these have the same bases here, so what we do in this division is we subtract the exponents. So it's going to be 4 times b to the 3 minus negative 3. Those are the exponents, 3 minus negative 3, so we're going to get b to the 6th power times 4 equals 2. So I'm going to divide by 4, so I get b to the 6th equals 2 divided by 4, which is 1/2. And then I'm going to need to take the 6th root of that. So the 6th root of that, so b equals the 6th root of 1/2. Alright, so that's not a nice number, but we're going to use that as b. What we're going to need to do is figure out what the number is that's our a value. Okay, so let's look at this in terms of how much it decayed by. So I think that it went by from -3 to 3, that's 6 units, and it went from 4 to 2, that's dividing it in half, right? Okay, so let's take a look at this in terms of solving this. So we have f of x equals a times the 6th root of 1/2 to the x power. We need to put one of these two points in there to figure out what the value is for a. Now we could probably just put this in this equation. That's also will work, or this equation right here. So I'm going to put it into this equation, the red one, or let's just use one of the points. We'll use the blue point -3, 4. So we're going to put in 4 right here. A times the 6th root of 1/2 to the -3 power. Okay. All right. Now, we need to know how to operate with these two things. Now, this is actually an exponent. We could change this to an exponent so that we can multiply the exponents together. In this case, this exponent, this root exponent, is going to be a to the 1/2 to the 1/6 power, and then all to the -3. So this root is 1/6 because it's basically a 6th root. It's the reciprocal of the 6th power. So that's what we would use here. Now if we multiply these together, since they're power on power, that's going to be 1/2 to the -3/6, or -1/2 power. And that would be negative exponents being reciprocals. So there's a lot of definitions here. We're using negative means reciprocal, so we need to take the reciprocal of this. That's 2 to the 1/2 power. So it's going to be this is going to be the square root of 2. 1/2 power is this second root of 2. And so our a value here is 4 divided by the square root of 2. Which is, in this case, can be simplified. What we do is what we call rationalize. So we multiply the top and the bottom by the square root of 2. That's going to equal 1. When we multiply by that, we get 4 square root of 2 over the square root of 4, which we know is 2. So we get 4 square root of 2 over 2, which is 2 square root of 2. So this is our a value on this problem, 2 square root of 2. Okay, so that means our equation, this is a tough one, is f of x equals 2 square root of 2 times 6th root of 1/2 the x power. Alright, so that's very possible. It just takes a lot of work with the definition of every power rule. So we have to know what negative powers mean, we need to know what dividing means, we need to know what roots of powers mean. So we need those definitions to solve this. Okay, and that was one of the most difficult ones on the homework assignment, where you had these 2 points and you come up with this solution of f of x equals this 2 square root of 2 times the 6th root of 1/2 of x. Now this is not standard notation here as well. In reality, that would be the square root. We would have to rationalize that as well, like we rationalized this one, to get the actual true nice solution here. So but this one we only multiplied by the square root of 2, and this one we'd have to multiply by the 6th root of 2 to the 5th power, just so that we can get rid of the 2 on the bottom. So in reality, this is the 6th root of 2 to the 5th power over 2 for this problem. But this would be fine for what you have for this purpose. Alright, I want to take a look at just 2 more examples of this for this video. 2 examples are from your book 26 and 27. We're going to try to find the value in a problem given a growth rate. Okay, so let's do 26 first. 26 says an investment of $11,000 in the year 1995. It appreciated to $14,000 in 2008. With what is the current annual growth rate? And assume the value continues to grow by the percentage. What's the value in 2012? So what we have to do is we have to come up with an equation for this. All right, so we have our equation. We're going to use f of t this time because it's time. So this is 26 equals a times b to the t power. All right, we know our points are going to be, the first point is going to be considered as 0, so 1995 is going to be considered 0, and we're going to have 11,000 in that point. And the next year is 2008, so that's going to be the point 13, that's 13 years after 1995. And that's going to be 14,000 for the value. So we can do this the same way as we did the first example. We have the initial value, so we know what the initial point is. So we know $11,000 goes here, and then we just have to find the rate of growth here. And it's going to want to know what the annual growth rate is also. So we need to find that out. So in this case, we plug in our second point, 14,000 equals 11,000 times b to the 13th power. Okay, so we're going to divide 14,000 by 11,000, and we get 1.27 repeating. So this is going to be 1.27 repeating equals b to the 13th power. Now we're going to need to take the root, the 13th root, 1.2727 repeating, to get b. Now the 13th root is hard to do in a calculator, so what we're going to do is raise it to the power. As I said before, this is going to be the reciprocal power, so it's 1/13th power of 1.2727 repeating is going to equal b. So I'm going to take that value that I have and I'm going to raise it to the power of 1 over 13, 1 divided by 13 power, and I get 1.01087 to 4 decimal places. Okay, so this part right here, since I said before this is 1 plus the percent of growth or or minus, in this case we're going up, so this is going to be the part right here that's the percent. So my percent is going to be the decimal 0.0187, and if I convert that to a percent, that's 1.87%. So I'm growing by 1.87% on this one. That's my annual growth rate. Now if I want to know what's the year 2012, that's how many years after. So that means that my equation for this problem is going to be f of t equals 11,000, 1.0187 to the t power. That's my equation. Now, I'm going to use that equation for the year 2012. So we don't put 2012 in there because 2012, the thing starts at 1995. So we're going to go 2012 minus 1995 to find my t value that I'm going to stick in right here. Alright, so that's going to be 5 and 12, so that's 17. So we're going to find f of 17 is 11,000. 1.08187 to the 17th power, and I'm going to use my calculator to do that. And I get $15,072. So I get $15,072 and 31 cents. If it's a money amount, I can go out to the penny here. So that would be my amount that I would have in the account in 2012. Right. All right, so the second example here is the same type of example, but it's going to be depreciating. So we're going to do, instead of 1 plus the growth, we're going to do 1 minus. Okay, so that's the only difference between the next example that we're going to do here. So we started at 38,000 in the year 2003. We depreciated to 11,000 by the year 2009. Okay, and then it assumes what would happen by the year 2013. So 2003, so this is number 27. So 2003 is 38,000, and 2009 is 11,000. Okay, so we wouldn't use these values. We would change these to 0 and 38,000, so that 0 is going to be your 2003, and this would be 3, that'd be 6 years after that, would be 11,000. So this is my initial value, so that starts to help me get the equation. My equation is going to be f of t equals 38,000 times b to the t power. Now I'm going to plug in these values here, so I get 11,000 equals 38,000 times b to the 6th power. Okay, I'm going to divide the two numbers. 11,000 divided by 38,000, I get 0.2895 equals b to the 6th power. I need to take the 6th root of 0.2895 to get b, so that I have to do that in my calculator to a power of 1/6 get b. Okay, so I'm going to raise that to the 1/6 power. I kept all the decimals in my calculator, and I just pushed raised to the power of 1/6, and I got b is equal to 0.8133, 4 decimal places. Okay, so my equation is f of t equals 38,000 times 0.8133 to the t power. Now, this is going to tell us what our decaying rate is. If we go 1 minus 0.8133, we're going to get 0.1867. So this is my rate of decay, or of depreciation in this case. So we'd say we're depreciating 18%, 18.67% depreciation per year. Okay, that's what we're getting out of this thing, is depreciating that much every year. Now we want to know what the value is in 2013. So I'm still going to go back up to here to get 2013 question mark. What is that? So I'm not going to put that in for t. Remember, we're going to start at 2003, so that is going to be at t equals 10. All right, so we just put in f of 10, and that's the answer I want. So I'm going to do that in the calculator. Again, 38,000 times 0.8133 raised to the power of 10. We would get 4,811.61. So this would be how much the car is worth after 10 years, in the year 2013. And this would be my equation for any depreciation I would have under that. Alright, so that's this first part.